you move farther away from a flagpole, the angle of elevation of its top increases.
Okay, let's do a little poll. Give me a fist. If you think the angle of elevation of its top is increasing, give me a thumbs up. And if you're like, well, I don't think so, give me a thumbs down. And if you're going, I cannot visualize it, give me a sideways. Side is fine, down is fine. All right, false is true. And I'm going to prove that to you by the visual. It says, as you move further away from the flagpole. So let's draw a flagpole. And you're pretty tall. And it says angle of elevation of the top. So I'm going to go to my top and draw my angle of elevation. And my angle of elevation must be from my vision. So that is my angle right there. And notice I use the horizontal and diagonal and not the what? Not the vertical. Now, are we getting closer or further away? Further away. So flagpole does not change. But you, the person, will go far, far, far away. How far doesn't matter. So now let's go ahead and draw the angle of elevation from the line of sight to the top. What happened to that angle? Did it get smaller or greater? Smaller. And this is saying, hey, it got bigger, which is false. So if you get stuck on it, just draw the image and draw the horizontal and diagonal, and it'll be visually there for you. Everyone go with that? Okay? All right, John, let's read number 6.
Find the nearest foot, the height of a vertical post, if its shadow is 18 feet long and the angle of the elevation of the sun is 38 degrees.
So we have angle of elevation. So where should I make my horizontal line, on the top or the bottom? If I need to go up, I need to start from the bottom. So here I have my bottom. And I'm going to highlight the elevation from diagonal and horizontal only. And this angle is my elevation. Do I know what that angle is by the given?
Yeah.
How many?
38.
38. And then it says the vertical post has a shadow. The shadow is 18 feet long. So the norm is that the shadow hits the where? The ground. And we want to know, find the nearest foot of the height of the vertical post. So that is what we're looking for. So let's label. Hypotenuse. When I jump, it's called the opposite. Then the remaining is my adjacent. So which trig function do I need if I'm looking for the opposite and given the adjacent? Tangent. So we have tangent of the angle, 38, is equal to the opposite x over 18. So now we're doing algebra 1. When you are dividing by 18, what do you do on both sides by the opposite? We multiply by 18. So that goes away. And I think I'm going to just go ahead and type it in. So we have, let's kind of anticipate something. 38 is less than that complement. So we know x has to be greater than or less than 18. Less than? Okay, let's check. 18 times tangent of 38. And let's see if it is less than 18. Press enter. Is that true? Yep. And it says nearest a foot. So we have x must be 14 foot. Okay, last one, number 12. Nev, let's read number 12, please.
A salvage ship is locating wreckage. The ship's sonar picks up a signal showing wreckage at an angle of depression measuring 12 degrees. The ocean charts for the region list an average depth of 40 meters. If a diver is lowered from the salvage ship at this point, how far can the diver expect to travel along the ocean floor to the wreckage?
Okay, so we want to first figure out how can we draw this triangle. Since this time I have angle of depression, and that means we're going down. Do I start with my horizontal line on the top or the bottom? Top. So there's my horizontal. There's my diagonal at the right angle. And let's highlight the angle of depression. Is that angle measurement given to us? How many? 12. And then it says on average, the depth, which is a vertical piece, is 40 meters. Oh no, my pen's dying. How do I know what part to find? Am I finding the diagonal or the horizontal? The diagonal, let's see. How far can the diver expect to travel along the ocean floor? Here's my ocean floor. So really, it's not the diagonal, but it's the what? The horizontal piece. All right, let's label. So we have our hypotenuse, we have the opposite, and the adjacent. It looks like we're using what trig function again? Tangent of 12 is equal to my 40 over the x. And let's see if you recall. When you have a variable on the bottom, what did we do? We took all of that and all of that, and we swapped. Okay, this pen is gone. So we have my x is equal to 40 over the tangent of 12. And then what's nice is now the x is by itself. Let's type them in. 40. And then we have tangent of, oh, not sine, tangent of 12. Okay, let's anticipate something. 12 degrees is very tiny, correct? Very, very small. So if that angle is way greater than 12, this side must be way bigger than 40. So when I press my enter, oh, is it way bigger than 40? It wasn't, I lied to you. Yeah, I made a mistake. Oh,
It's 40.
I put 40. I mean, instead of 40, what did I put? Silly.
Should be 100.
So embarrassing, right? Boom, that's a lot bigger. I was like, oh no, we broke math. And did it say what angle measurement? I mean, not angle, decimals? No. I think I'm gonna stick with the whole number. All good? Okay.